Close to the Sun, a small planet holds great mysteries. Mercury, tiny and fiery, has surprised us for years, but now space probes have discovered unexpected phenomena. They are said to have found diamonds on the hottest planet. And this is only the beginning. Mercury's interior is puzzling, too big, too strange. Why is it so different from the other planets, and what more secrets does it hide? Mercury, the smallest planet in our solar system, has captured the attention of astronomers and space enthusiasts alike. Its enigmatic landscape, hidden for centuries, began to unravel only with the advent of space exploration. The mission to unravel Mercury's mysteries began with NASA's Mariner 10 in 1973 and continued with the Messenger probe in 2004. Mariner 10, the first spacecraft to visit Mercury, provided the first close-up images of this elusive planet. During its flybys, it captured a terrain full of craters and strange ridges. Similar to our moon, this mission revealed a Mercury with a rough, cratered surface, along with a surprisingly strong magnetic field in a larger-than-expected core. These findings challenge scientists' assumptions about Mercury's composition. The Messenger mission, launched 31 years after Mariner 10, greatly expanded our knowledge of Mercury. Unlike its predecessor, Messenger was designed to enter orbit around the planet, allowing it for a much more detailed study. During its mission, Messenger captured some 200,000 images, revealing areas of Mercury never seen before. One of the most intriguing discoveries of the Messenger mission was the detection of unusually high levels of calcium and magnesium on the dark side of Mercury, raising questions about the processes that might have caused these concentrations. In addition, the mission found that Mercury's magnetic field was surprisingly strong in the northern regions, which was unexpected compared to other planets. These findings led scientists to reconsider Mercury's internal structure and its formation process, revealing that they were quite different from what was previously thought. On most planets like Earth, magnetic fields are generated by the motion of liquid iron in the core. However, Mercury's peculiar internal structure produces a different magnetic behavior. What makes Mercury's surface so special is not just its craters and ridges, but also the extreme conditions it faces. During the day, the temperatures on Mercury can reach a scorching 430 degrees Celsius or 806 Fahrenheit, which is enough to melt lead. At night, temperatures drop at frigid minus 180 degrees Celsius or 292 degrees Fahrenheit. This extreme thermal oscillation is due to Mercury's thin atmosphere, which barely regulates temperature or retain heat. Despite these harsh conditions, recent studies have revealed surprising features on Mercury's surface. In 2012, Messenger data showed signs of volcanic activity, including pyroclastic deposits from explosive eruptions. This discovery challenged the idea that Mercury was a geologically inactive planet. Even more intriguing, in 2020, scientists announced the presence of water ice in some of Mercury's polar craters. These permanently shaded areas are cold enough to hold ice, even on a planet so close to the Sun. This finding has raised new questions about the possibility of simple life forms on Mercury. Could extremophiles similar to those that inhabit hostile environments on Earth exist in these icy refuges? The most recent mission to Mercury, Bepi Colombo, launched in 2018 as a joint effort of the European Space Agency and the Japan Aerospace Exploration Agency, is scheduled to reach Mercury in 2025. This mission promises to provide new information about Mercury's surface, including its chemical composition and geological history. From its repressive magnetic field to the existence of water ice, Mercury never ceases to amaze us. But what we are about to discover will leave you speechless. How is it possible for a planet so close to the Sun to have a year shorter than its own day? When we think of planets, we usually imagine them spinning on their axis once a day and orbiting the Sun over the course of a year. Mercury, however, challenges this idea in a fascinating way. On this tiny sun-scorched world, a year is shorter than a day. Let's take a closer look at this. Mercury takes only 80 Earth days to complete one orbit around the Sun, which means that its year is much shorter than ours. But here's where things get really interesting. A single day on Mercury, for example, a complete rotation on its axis, lasts 176 Earth days. This means that a year on Mercury is only half as long as a day. This peculiar situation generates really strange effects. If you were on the surface of Mercury, you would see the sun gradually rise and glow in the sky as it slowly advances. At a certain point, the sun would appear to stop, recede briefly, and then continue on its original path. This strange dance occurs because Mercury's rotation cannot keep up with this rapid orbit. But what does Mercury rotate so slowly? Scientists believe is due to a phenomenon known as tidal coupling. For billions of years, the sun's gravitational pull has slowed Mercury's rotation. However, unlike our moon, which is completely synchronized with Earth, Mercury's is 3.2 resonance. This means that it rotates 3 times for every 2 orbits around the sun. But perhaps the most surprising discovery about Mercury's surface was made in 2022. Researchers studying data from the Messenger mission found traces of nitrogen trapped beneath Mercury's surface. This nitrogen could be a remnant of ancient atmosphere that was buried beneath the intense heat and solar radiation hitting the planet. The presence of subsurface nitrogen raises intriguing questions about Mercury's history. Could the planet have had a denser atmosphere in the past? If so, what implications would have this had for this early climate and possible habitability? Another fascinating aspect of Mercury's hidden depths is the existence of water ice in the permanently shadowed craters near its poles. Although this ice is found on the surface, it is hidden from direct view and protected by the extreme cold in these perpetually shadowed areas. Recent studies suggest that some of this ice may be relatively recent, perhaps deposited by comets or asteroids in the last few million years. In addition to water, these polar craters also contain dark deposits that scientists believe may be organic compounds. These materials, which appear to be more volatile than water ice, could be remnants of comets or asteroids that impacted Mercury. The preservation of these organic compounds in Mercury's subsurface offers a unique opportunity to study the distribution of organic matter in the inner solar system. The discovery of these organic compounds in Mercury's polar craters is particularly intriguing because it challenges our understanding of how such materials can survive in harsh environments. Mercury is the closest planet to the Sun, and its surface experiences extreme temperatures ranging from scorching heat on the sunlit side to freezing cold in the shadows. Despite these conditions, the permanently shadowed regions within the polar craters create a stable environment where volatile compounds can persist for millions or even billions of years. These organic materials are of great interest to scientists because they are the building blocks of life. While there is no expectation for life to exist on Mercury, the presence of organic suggests that the raw ingredients necessary for life are more widespread throughout the solar system than previously thought. This raises important questions about the early solar system and how organic compounds were distributed and preserved across different planetary bodies. The origin of these organics on Mercury is still a subject of investigation. One hypothesis is that they were delivered by comets or asteroids that bombarded the planet during its early history. Comets in particular are known to be rich in organic molecules, and their impacts could have deposited these materials onto Mercury's surface. If this is the case, it would provide valuable insights into how the processes that can generate complex compounds in extreme conditions and environments work. Let me know what you think in the comments box. If you liked the video, hit the like button and subscribe.